Welcome back on this terrific No Snow Tuesday. Now let's take a look at some more brain knowledge. So keep your page going to the reciprocal trigonometric ratios. So far, we've been entirely concerned with the primary trigonometric ratios, which, just to recap, are SOHCAHTOA. SOH gives me sine. Sine theta is opposite over hypotenuse. So if I have an angle here drawn in standard position with some endpoint xy, and this is h, sine theta here would be, here my opposite would be the y value, so that would be y over h is sine theta. Okay, and then we also have cosine theta, which is so CAH, C-A-H, so this is adjacent over hypotenuse. That would be the x value over the hypotenuse. And then tan theta is opposite over adjacent, or y over x. So these are my primary trigonometric ratios. Now we're going to look at the secondary trigonometric ratios. And if you know your primary trigonometric ratios, you already know your secondary trigonometric ratios. There's not that much new to learn here. They are the reciprocals of the primary ones, meaning flip them. Flip that fraction for me, please. So here, the cosecant, it's also written CSC of theta, is the reciprocal of sine. And this is something that I have a trick that I use to memorize. There's going to be pairs of flipped ratios. Cosecant is the flipped sine. Secant is the flipped cosine. And cotangent is the flipped tangent. In every pair, there's always one co. Secant are my flipped sines and cosines. So cosecant has to go with sine because sine is not co. We need one co in that pair. That's how I remember. Otherwise, I will forget. We don't use these that often, but they are useful in setting up problems if you want the hypotenuse on the top. So here, I would write cosecant theta as equal to h over o. Hypotenuse over opposite is my cosecant. Secant is just the flipped cosine. Notice that it's not cosecant, and so it goes with cosine. There has to be one co in each pair for some reason. So that's, by definition, secant is hypotenuse over adjacent. And cotangent is just the flipped of tangent. So there, if I flip tangent, tangent's usually opposite over adjacent. 1 over tan is adjacent over opposite. Another thing to point out is this is a good way to remember your fractions rules. If I divide 1 over tangent, but tangent is just opposite over adjacent, that's the same thing as flipping this and multiplying by the top. So it's like 1 times adjacent over opposite, or it's just adjacent over opposite. So to use these on your calculator, you're going to have a special button that's a reciprocal key. It might look like this, or it might look like that. We remember from looking at exponentials that x to the negative 1 can be written as 1 over x. The negative exponent just throws the base to the bottom of a fraction. That's all the negative exponent does. So that's your button that might do this on your calculator. You could use the x to the y button, or you may have a button that looks like that. That's the reciprocal button. Another way to do it is you say, well, I can type in, let's say I want to know secant of 123 degrees. Okay, and I know that's going to be equal to 1 over the cosine of 123. Okay, so what I can type on my calculator is I can type cosine 123, and it will output that for me. And then if I don't know where this button is, or I forget where it is, I often have trouble struggling finding buttons on calculators. All you need to do is say 1 divided by, and then push your answer button. And it pulls up your most recent answer on the calculator. You'll have 1 over the answer, and it will give you the secant. So that's another way that you can do this on your calculator. Okay. So now let's determine the 6 trigonometric ratios for 123 degrees. Okay, this is a calculator question. So this is a good time to tune up your calculator skills and try it out. So when I type sine 123, that gives me 0.836. So I have sine of 123 degrees equals 0.8387. Keeping 4 decimal places on a trigonometric ratio, that's a lot of accuracy. A lot. Now, if I want to know the cosecant, the CSC of 123, that's going to be 1 divided by that. So I can just do my inverse button, and I found it on this calculator the other day. There it is. So I go second function, that equals 1.1924. 1.1924. Notice that sine will always output values between -1 and 1. They'll always be decimal numbers, almost always, unless it's -1 or 1 or 0. But it'll be all those decimals between -1 and 1. Cosecant will give you numbers as small as 1 or as small as -1, but it will also give you bigger numbers because we're just looking at the reciprocal of that. So it also goes up to infinity as well and beyond. Now, if we look at cosine of 123, cosine of 123 degrees, and then I just punched out on my calculator, cosine 123 equals negative 0.5446. So check your answers on your calculator, make sure you're getting the same thing. And then to find the inverse of that, I just use my inverse button and equals. And so the secant is related to cosine, SEC, secant, because this already has a cos, so this doesn't want to be cosecant, it's just secant of 123. And when I flip this on my calculator, I get negative 1.8361. I would do the same thing if I divided 1 by this, it would give me that. Okay. And then tangent of 123, punch it on calculator, gives me negative 1.599. Yeah, we're getting calculators tuned up, so if you're not getting this, I'll visit you after, and we'll make sure we set up your calculator correctly. And then the cotan, I just flip it, use my flip button, and that's negative 0.6. And cotan is written COT, cotangent of 123 degrees, equals negative 0.6494. There's just some new definitions here. So if I have this triangle here, a 6, 8, 10 triangle, is that a right angle triangle? How do you know? Because there's a little square there. What if we didn't have a, what if I said prove that this is a right angle triangle? How would you do it? Does this correspond to Pythagorean theorem? Usually we get weird square roots and stuff with Pythagorean theorem. Why does this one work? Yeah. So this is 36. This is 68. 36 plus 68 is 100. The square root of 100 is 10. So this one does correspond. Another answer that you could give me is this is just a variation of the 3, 4, 5 triangle blown up to double size. So if you memorize your Pythagorean triples, 3, 4, 5, and 5, 12, 13, these are useful ideas that you can use to solve a lot of triangle problems, especially triangle problems created by math teachers, because we like these things to work out on the integers. Gives you a sense of satisfaction when your answer snaps to an integer. It's kind of nice. Okay, so anyway, if we want to look at secant, so secant, I already remember which is the primary ratio that's related to secant. Who can remember? Yeah. Yeah, cosine. Because cosine has a co, and secant doesn't, so we need the one that has a co. And cotangent is obviously related to tangent, because it's the co of tangent. So here, this is 1 over cosine. Here is the angle A. So I need the adjacent and the hypotenuse. So that's equal to 1 over cos A. Well, that's 1 over 6 over 10. And that would simplify to 10 over 6, when I flip this and multiply, that'd be secant of A. And that's also equal to, I can simplify 5 over 3 because we have this triangle hiding inside there. We could use this triangle as well because that's also angle A. It's the same angle there and there because they're similar triangles. Which 3? This one? Yeah. Oh, I was just showing you that this 6, 4, 6, 8, 10 triangle is a variation of a 3, 4, 5 triangle. Yeah, I just cut it in half there. That's supposed to be cutting this in half. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. So that's one of the Pythagorean triples, where all 3 of those ABC fall on integers. And yeah, so yeah, we don't, strictly speaking, need that for this problem. Okay. Now let's take a look at the other 2 reciprocal ones. This is cosecant. So if secant is related to cosine, cosecant is related to sine. So this is 1 over sine A. And I'm looking at here, my angle of interest is A, this angle here. And the opposite side to A is 8. And then the hypotenuse is 10. So we could use 1 over sine A to calculate this, but let's just go straight to cosecant is equal to this over this. It's 10 over 8, which simplifies to 5 over 4. Okay. So there's cosecant. This one, secant. And then cotan. Cotangent is related to tangent. It's right there in the name. So tangent is opposite over adjacent. People are comfortable with this being the opposite side to that angle, right? And this is the adjacent side. It's right there. So this is opposite over adjacent is tangent. So if we flip that, that's cotangent. So what's the cotangent of A? Did you say 6 over 8? Yeah, 6 over 8. Good. Adjacent over opposite is cotangent. So it's just tangent flipped. Tan is TOA. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. So we say 6 over 8, which is 3 over 4. There's cotangent, 3 over 4. 3 over 4. Okay, so now we have the point negative 3, 5. It lies on the terminal arm of an angle in standard position. Determine exact expressions for the 6 trigonometric ratios for the angle. So, again, I'm already noticing that, wow, why don't we use this? Oh, we can do it this way. It's much nicer. Okay, so here, negative 3, 5. There's my point, negative 3, 5. All right, and we are interested in this angle here. Call it theta. Okay, and we want to know the primary trigonometric ratios for that. So let's zoom in a little bit. We'll draw our triangle here. So I've done the first 2 steps, which is plot the point and then join the point to the origin. And then I want to consider this triangle here, which is going to be the, this angle here is the reference angle for this angle theta. So this is angle beta. And this is a height 5. And this is a negative 3. And this side length here, well, I do 5 squared plus 3 squared to find this. 5 squared, 25. Negative 3 squared, positive 9. So 25 plus 9, 34. So this is the square root of 34 long. A little bit shorter than 6. Because 6 would be the square root of 34. It's like 5.8, somewhere in there. So now we can write down sine of this angle is equal to opposite over adjacent. Here's the opposite. Here is the, opposite over hypotenuse. So sine theta would be equal to 5 over 34. Square root of that, though, please. 5 over the square root of 34. It's almost 1, because we already talked about this, just a little bit smaller than 6. It's 0.8574. Sounds great. Yeah, and then cosine of theta would be equal to adjacent over this. So that would be negative 3 over square root of 34. And tangent of theta, well, that would be opposite over adjacent. So this one is the adjacent side. The x value is always the adjacent side. The y value is always the opposite side. So it's going to be x over y for tangent, and that's negative 3 over 5. Now I can use those and just flip them to get my other other three trigonometric ratios to make 6. So sine is related to which of the new reciprocal trigonometric identities? Cosecant. Yeah, good. So cosecant of theta is equal to, what's it equal to if sine is this?
Square root of 34 over 5.
Great. Yeah. It's just definitions today. It's not a lot of like brain challenging stuff. Secant, S-E-C, secant of theta is equal to the square root of 34. But we can say the negative square root of 34 over 3. When we flip it, we might as well leave that negative on top. It's a little nicer. And then tan theta, negative 3 over 5. So cotan,
Negative 5 over 3.
no, negative 5 over 3. Good. So those are our reciprocal trigonometric identities for those. So now we want to know two angles to the nearest degree have a secant of 3. Okay. So let's find some angles that have a secant of 3, and we want to find those angles to the nearest degree between 0 and 360. There will be two. There'll be two angles. They'll be in different quadrants. So secant is related to which of our trigonometric identities? Yeah, so if I have secant of theta, we're looking for angle theta. That's our unknown. It's equal to 3. So I know that cosine of theta will be equal to what? 1 over 3. 1/3. So now I can calculate theta by taking the inverse cosine of both sides. This is what you will punch on your calculator to find me this. $70.5. We've been asked for to the nearest degree.
So 71.
71 degrees. So theta is equal to 71 degrees. So we're halfway done. So I know now that this angle, 71 degrees here, could be finishing at the point 1,3. That could go through the point 1,3. 3 in the y. Oh, I'm sorry. Other way around. Wait. Huh? Yeah. 3 in the y. Secant of 3. Cosine is 1 over 3. What? 71 degrees? What? Yeah. Huh? Yeah. What? No, the cosine is 1 over 3. No, it's not. It's not that point at all. No, I'm confused. 71 degrees is this point up here. What is it? Well, that's not important. We weren't asked for that. I can calculate, but I don't want to right now. Okay, so 71 degrees. What would be another angle related to this angle that has the same cosine? So where would I go for another angle that has the same cosine as 71 degrees, meaning it has the same sine? And here's a hint. So in this quadrant, cosine is positive. In this quadrant, all the trigonometric ratios are positive. In this quadrant, sine is positive, and in this quadrant, tangent is positive. So where would you go looking for another angle that has the same cosine as that angle? In the fourth quadrant. We're going to look down here. So if I drew another angle here, like this, that also made a 71 degree angle with the x-axis, that point would have the same cosine as this point. Or that angle would have the same cosine as that angle. What's that angle? Could be negative 71. Negative 71 is a good answer. So the angle, so theta is equal to 71 or negative 71 degrees. If I said give me a positive angle, what would that be? Negative 71 degrees.
289.
289. 360 minus that. And why is it 360 minus that? Because this angle is 360 degrees minus 71 degrees. Okay, so that would be or 289 degrees. Hello, Drea. Thank you very much. Okay, cool. So blah, 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 blah. Determine exact trigonometric ratios. We're not ready for that one yet. Let's go to now looking at special angles. So now we're going to shift topics a little bit and look at the special angles and complete our investigations today of the unit circle. So we have here the unit circle. All right. It's a circle, and it has a radius 1. I think it got hit with some sanitizer. It should be very clean for you if it's the last one available.
Oh.
Thank you, Drea. Sorry. When we use the unit circle, the hypotenuse is always going to be 1. That's going to make it very convenient to find the points along the circle as trigonometric values. And so here we're going to see the connections between circles and trigonometry. And this is a connection that we're going to see expanded when we look at things like the trigonometric functions, like sine function, which is a wave-like thing, and you look at the day length over the year. The Earth is a big circle, and it turns, and we are 1 point on that circle. So you can think of us as an XYZ coordinate on that circle, connected by right-angle triangles that rotate around the Earth. And as we move around the sun, the day length changes according to trigonometry. So we see lots of connections between circles, triangles, and the various ways that those move in space and the language of the universe, and we see that here in trigonometry now. Not just triangles anymore, but also circles. So when we're looking at the unit circle, because the radius is 1, we can show that the x value of any point on this circle is cosine of theta, and the y value is sine of theta. So let's draw a terminal arm here. We're going to start from the initial arm here at x, and we're going to rise up, let's say, oh, I'm not drawing. There we go. Let's go up 30 degrees to there. Okay? So here, this is the 30-degree angle that I've drawn over here. We've already given you 30 degrees there. Oh. And the x value is cosine of 30 degrees, because this is 1. This is a radius 1. It's 1 over here, it's 1 over there, it's 1 all the way around a circle. That's the definition of a circle, a constant radius. And then, if I lift that by 30 degrees, that would create this triangle. The x value here would be cosine of 30 degrees. The y value would be sine of 30 degrees. So every point on the unit circle can be represented by this point, depending on the angle there. Okay? And how is that interesting? How does that help us? Well, 30 degrees, this is a special triangle. All right? I think we're going to talk about the triangle. And yeah, do we have that chart here on the handout? I have a copy of the handout. No, we don't? Let's see. So we are now on the back page. And we are going to jump down here to special right triangles. So we're going to be investigating 2 of these special right triangles, the 45-90-45 triangle and the 30-90-60 triangle. And the special nature of these triangles is going to allow us to get exact answers rather than decimal approximations for the values of sine, cosine, and tangent. So to create the special triangles, if we go and look at the 45-90-45 triangle, here's an angle 45 degrees. I know that this side should be 1, and that side should be 1. And if this is 1, and that's 1, then this side here would be 1 squared plus 1 squared. 1 squared is 1. So 1 plus 1 is 2. And this side here would be then the square root of 2. So for this triangle, what is the cosine of 45 degrees?
0.071.
Yeah, but if I wanted to give that exactly, I'm going to use the adjacent side and the hypotenuse in my answer to give cosine of 45. So it's
1 over square root.
Yeah. So you're going to see this as 1 over the square root of 2. You're also going to see this as square root of 2 over 2. Some of your calculators will output this. Why are these two things the same?
You multiply both the bottom and the top by the square root of 2.
Yeah, that's one way to think about it. Another way is to use your exponentials. And you know that the square root of 2 is the same thing as 2 to the 1/2. So if I have 1 over the square root of 2, that's the same thing as saying 2 raised to the power negative 1 over 2. Put that to the bottom, and it's the square root, so that's 2 to the negative 1 over 2. If I look at this one here, I can think about that as 2 to the negative 1 over 2 divided by 2 to the 1. And then I use my, this is 2 to the 1 over 2, not negative 1 over 2. There. So it's 2 to the 1/2 divided by 2 to the 1. When I'm dividing things of the same power, I subtract the exponents. So 1/2 minus 1 is negative 1/2. Means 1 over root 2. So all of these are just different ways of writing the same thing. Now, sine 45, sine and cosine, they are the same here because the opposite and the adjacent are the same. This is an isosceles triangle when we have a 45-degree angle and another 45-degree angle and the other one 90. So these two sides are the same. This is the isosceles 90-degree right angle triangle. It's the only one. Okay? And so sine 45 is going to be the same thing, 1 over square root of 2. And tan 45 is equal to what? What's tan 45 here? I'll give you a hint. It's the same thing as cotangent of 45 degrees. Because if I flip it, it's the same thing. Oops. So what is it?
Same thing as 1 over.
Yeah, well, what's tan 45 then?
1 over.
I know it's killing you.
Would it be the same as sine 45?
No, because sine and cosine both use the hypotenuse, which is the odd one out of these three. Damon?
Would you just write 1 or would you still write it as fraction?
We'll just write it 1. Yeah, your calculator is just going to tell you 1.0. It's going to tell you 1. Because this tangent of 45, this is where tangent is 1. It's where the ratio between these two sides is, they are the same. They're 1. So tangent is 1 for a 45-degree triangle. Okay. So that's the 45, 90, 45 triangle. But now, let's take a look at how we can create the 30-degree right angle triangle. And this one you can draw on here. So we looked at the isosceles right angle triangle. Just to review, there's 3 types of triangles. Scalene, which is 3 sides all different. Isosceles, which is 2 sides the same, 1 side different. And then there's equilateral, or all 3 triangles are the same size. Also, all 3 sides are the same length. Is there such a thing as an equilateral right angle triangle? No, there's not. But I could create 2 scalene triangles like this that if I put them together are an equilateral triangle. See this one here? What's the interior angle of an equilateral triangle? What's one of the interior angles of an equilateral triangle? 45 plus 45 plus 45, that's not 180. It's going to be 60. Yeah. So 180 divided by 3, because all the 3 angles are the same, 60. So if I'm looking at 1/2 of those, this would be 30 degrees. And this gives us our 30, 60 degrees, and then here's our 90. This is the 30, 60, 90 triangle. And it's a very special triangle. It has a very special property with its sines and cosines. And we're just going to take a look at that now. Here, if we say that this side here, well, how big is that? Well, I know that this side length is 1. And this is how long here? It's an equilateral triangle. If this one is 1, how long is this one?
1.
1. So this side here This would be the point something in the x, and I don't know why I can't slide over more than that. Why can't I slide over more? Just zoom out then. Oh, because I zoomed in the improper way. So this is 1/2 in the y. It's 1/2 the height of its hypotenuse. And then if this is 1/2 and this is 1, we can actually create a scaled up version of that will look like this. Okay, I'm just going to double the sizes. So this is 2. This is now 2 long, so this would be 1. And if I want to know then the other missing side of this 30-degree, 60-degree triangle, what would the length of this side be? Yeah.
Square root 3.
Yeah. So here, I would have to use a squared plus b squared equals c squared. Sorry, a squared equals b squared plus c squared is usually how we write this, Mr. Jennings. And I don't know this side here. Call it b. So, but I know a is 2 squared, so that's 4, is equal to b squared plus 1 squared. And then I just subtract 1 from both sides because 1 squared is 1. So that would be 3 is equal to b squared, and then b is equal to square root of 3. So this is, you'll also call these the 1, 2, root 3 triangle. 1, 2, root 3. This side here is root 3 high, root 3 long there. Okay. Now, when we're looking at this one, the 30, 60, 90 triangle, we have our 1, 2, root 3 there. So this is 30 degrees, and we just showed that with an equilateral triangle cut in half. And then, so here, what would cosine of 30 be? Let's actually take a look at sine 30 first. What's the sine of 30 degrees? I know you know. You've known this for since the start of the unit. Sine is, you have to go through it in your mind to get value from this type of exercise. Sine is opposite over hypotenuse. What's my opposite here?
1 over 1, the square root of 3.
Well, opposite over hypotenuse.
Oh, hypotenuse, then 1 over 2.
Yeah, so sine 30 is 1 over 2. And cosine of 30 then is, go through it in your mind. Cosine is adjacent over hypotenuse. I have looked at the adjacent here. It's root 3. Because 2 squared is 4, 1 squared is 1. 1 plus 3 gives me 4. So this would be root 3 over 2 is cosine of 30. Let me write that more beautifully. Square root of 3 over 2 equals cos 30. If you're asked for an exact value of cosine of 30, give them root 3 over 2. Don't tell them 1.7 divided by 2. Tell them root 3 over 2. And then they will say, thank you very much. And then tan 30, opposite over adjacent, tangent, TOA. Tangent is opposite over adjacent. Here's my opposite, here's my adjacent. So I put 1 over root 3. You have to do it in your mind. You have to do it yourself. Okay. So there we go. That's for a 30, 60, 90 triangle, or a 1, 2, root 3 triangle. Now we take a look at the 60 degrees. So now if we're looking from this side here, now this is our angle of interest, and we are looking at that one. We have beautiful eyelashes. And we're interested now in cosine of 60 degrees. So cosine for 60, what's that?
One over 2.
Yeah, great. Cosine 60 equals 1/2. Adjacent over hypotenuse. Very good. Sine 60.
Square root of 3 over 2.
Yeah, this is root 3 over 2. Good. So opposite over 2. Opposite over hypotenuse is sine. And tangent 60.
Root 3.
Good answer. Root 3. Root 3 over 1. Root 3. Good. Very good, very good, very good. So these are our special angles, 30, 45, and 60. 90-degree angles are also special. And yeah, we can look at that later. Yeah, so we can use this to solve for exact answers. So let's see. What do we have here? Have I asked you to do any of those? No. That's everything that I wanted to cover. So now we should be set up to answer some more practice problems and get ourselves ready for the quiz. The topics that you will have on the quiz are angles in standard position, special angles, and reciprocal identities. So we want to know these angles in the special angles, the 30-degree angles, the 45-degree angles, and the 90-degree angles won't hurt either. So let's go back quickly to take a look at 90-degree angles here. It's not hard to find your special angles for 90 degrees. You can just punch them on the calculator because they're all going to be 0, 1, or -1. So if the angle is 0, we can draw that like this. Here's an angle that is 0 degrees. It's right there. So it's going to have some x value and then a y value that's 0. This could be the point 3, 0, for example. That's an angle with 0 degrees. The cosine of that is going to be 1. The sine of that is going to be 0. Why? Because it's 3 long, and so the adjacent side is also 3, so that's 3 divided by 3 is 1. Sine, well, it has no y. It's 0, so that's just 0. The tangent is sine divided by cosine. That's another way to do tangent. But tangent's also x over y. Because y is 0, this is undefined. Wait. No, this is opposite over adjacent. Yeah, so it's 0. Yeah, that's 0. For 90 degrees, this is a 90-degree angle here. It could be up here at point 0.03. So it has an x of 0, a y of 3. So its cosine is 0, its sine is 1, and its tangent is undefined. Because here, my x is 0, so my cosine is 0, and I can't divide by 0, so I have to call that undefined. Oh, 180, that's over here. Cosine is negative, so that's -1. Sine is 0, and tangent is -0. It's just 0. And then here, 270, that's down here. So cosine is again 0, sine is -1, and tangent is there undefined again. 360 is the same as 0. These your calculator will tell you. All right, practice questions here. Definitely bring me by to ask me questions if you're struggling with pieces of this material. And we still have a good 20 minutes at least to do some practice while you're here. I didn't make a delta math for today because I thought that this was a lot of textbook practice. Right? If people prefer delta math, you can do delta math practice and I could make it. So Drea says, yes, do that. So I'll do that immediately. Remember, the delta math is not required. The textbook practice is also not required. What's required is that you know this stuff for tomorrow. That way we can build on that knowledge with new concepts.